Welcome to our very first edition of Talk Universe. This is our show for Wednesday, July 13th, 2016. I'm your host, Sir Charles Schultz. We're going to be talking about science and technology and how it affects you and the society and how you live. Tonight's show, are we in a virtual world? A lot of scientists think that we are, so let's look at that. If we are in a virtual world, is there some sort of test that we can perform that will show us one way or the other? We will be taking your questions and ideas in the second half of the show. Each show on Talk Universe will have a specific topic that we address, and we'll also have a feature called Singularity Watch. This is where we look at the advances in science that seem to be bringing us to some unpredictable and amazing point in our future. Briefly, the singularity is a point in history where we can no longer predict what happens next. Many people believe that it will be tied deeply to advances in artificial intelligence and the extremely rapid development of human knowledge. Others feel that our advances in life extension and what is known as transhumanism will be the cause. The reality is we're learning so rapidly now that human knowledge is doubling in a period of roughly a year. In the years leading up to 1900, it's estimated that knowledge doubled every century or so, but the time to learn new facts and add them to our skills has dropped rapidly, and now it takes about a year. So what happens when it takes a month or a day or an hour to double the amount of human knowledge? The fact is, nobody can possibly predict what will happen then. We'll try to present science stories that indicate just how rapidly the change is coming, and we'll also discuss some of the potential implications, just what it might mean for the planet. I would also like to possibly focus on specific people who, in my estimation, have made notable contributions to such fields as life extension, medicine, physics, or space science. We'll look at the good and the bad, and we'll try to see the threats as well as the hopeful side of it all. If you want to participate in Talk Universe, go to our website at talkuniverse.org and register. We also have a forum button so you can have discussions, share your questions and ideas, and we'll be listening to those and presenting them on the show. We'll be building a library of shows and also creating a set of video tutorials showing you how to build robots, create a great workshop, program devices, and learn basic skills in science and technology. If you have children who have science projects, or if you just want to improve your personal skills without taking on $50,000 in educational loans, this is the site for you. Our goal is to inform you and share with you some of the key skills and ideas of science and technology. It's also meant to be fun and to make you think. Question the world around you. So, at the 17th annual Isaac Asimov debate, which was hosted this year at the American Museum of Natural History, this was the foremost question: are we in a virtual world? Neil deGrasse Tyson, who's the director of the museum's Hayden Planetarium, hosted the event with 5 scientists, from astrophysicists to cosmologists and a philosopher. Now, each brought a specific view to the table and some very interesting ideas about what we might look for. It was suggested that if we studied cosmic rays, for example, they might show signs of a graininess of the universe, sort of like magnifying a video image produces pixels. One of the ideas is that an energetic, massive particle, which is what cosmic rays are, may be influenced by the uncountable tiny, grainy structures of space-time as it passes through billions of light years of space. Now, other evidence might be in the spectra of energies from these particles. So imagine looking through a poor lens and seeing the color fringes of an image through that lens, where tiny distortions occur, where the properties of the glass cause the light waves to separate by frequency. If any of us has ever looked through a cheap telescope, we've noticed that the image sometimes has a red edge on one side and a blue edge on the other. This is called chromatic aberration, and telescopes are designed to eliminate the effect by using special types of glass and shapes of lenses arranged to cancel the effect out. But physical processes have no definite sign of this, and some feel it wouldn't make a difference. But after all, if the universe is a simulation, then it's possible that any answer we get might also be simulated to appear correct. It's this mathematical structure of atomic particles and how they work that gets some scientists thinking about the potential for the universe to be very much like a video game. I mean, if you think of the atoms as being tiny solid pixels, or the particles that the atoms are made of being tiny solid pixels, you can see how this would be a very inviting idea. But if this is true, then there may be signs of shortcuts taken in the simulation to make things appear more realistic than they actually are. We'd have to be pretty clever to find out if this is really a fact. To give an example, when we calculate the movement of a planet or a satellite in orbit, let's say, we use a method where the mass of the planet or the object is considered to be a single point, and not an extended body with real measurements and dimensions. We treat it like what's called a point mass solution. A true reality would most likely work by adding up all the forces on all the particles of all the atoms of an object, but that sort of calculation, in a computer sense, would be completely impossible for us or any computer. When we work out the path of a spacecraft, we treat it as a point, as well as the sun, the moon, the planets, and anything that might influence its movement. Even video games use this approach because it works so well. With no more than some tiny minor corrections, we can send a spacecraft anywhere in the solar system with extremely good accuracy. It was said that the Juno spacecraft arrived at Jupiter within 1 second of its predicted arrival time, just to give you an example of how close or how accurate we can be. So we can see that some shortcuts would work if we created a virtual world that has real astronomy going on in it. But that leads us to ask, are there other shortcuts that might allow us to create a very realistic virtual world? And if so, might we look for those shortcuts in our own world? What really makes many scientists unsure is the fact that many parts of nature appear to have self-correcting codes built in them. The equations that spell out superstring theory, one of the theories that might explain the physics of our universe, appear to contain error-correcting codes in them. And this is also true for DNA, which is the source code for living organisms. But it's also pointed out that a universe that allowed for errors to grow and propagate without correction would probably be unstable, and so we might expect to find error correction built into a universe, any one that's reasonable anyway. So what would it mean if we did find out that the universe is a simulation? Well, first of all, it might be useful to understand why people even ask the question to begin with, because there are a lot of possible theories that explain the type of universe we live in and how it's structured and why it works the way it does. Why would we even ask the question, are we in a simulation? Unlikely as it seems, science fiction seems to be the source of this, and stories written back in the 1950s and 60s covered the idea pretty nicely. And the idea in many of them was somebody discovers they live in this bubble of reality or a simulation of reality in one form or another. And a lot of it has ended up in movies. One of my favorites was the story Simulacron 3 that was written in 1964 by Daniel F. Galloway. And it became the basis of the movie The 13th Floor. And in that movie, one of the characters actually ends up escaping the simulation and emerging into what he feels is the real world. So why the fascination with this? It really started when we began simulating things using computers. Initially, computers weren't very powerful, and many of them actually used analog hardware such as gears and wheels and ratios to get things to happen. And in them, normally they would simulate something such as the flight of an aircraft or the movement of a shell, an artillery shell, a trajectory. And these devices were used a lot in ships for naval battles and defense. But as computers became more electronic and digital and achieved higher resolution, simulations became better and better, and we began simulating things such as the weather or the movement of populations of animals or how things change in our world. And a lot of it had to do with science and physics, but there were always the playful few of the programmers who would get into the system and simulate something nobody had thought about, or play around with it a little, so to speak. And so today, we know that one of the first major uses in the public world for computing was not just credit cards and designing new aircraft, but was actually for video games. And Nolan Bushnell, the fellow who invented the game Pong, converted it from a game that ran on his oscilloscope to something that could run on a television screen, and it became a real success, and Atari grew from that. Now, as our games have become more sophisticated, it reached a point where people question, what would it be like to be a video game character, and how much resolution does it take to make a video game as real as our reality? And so this idea has been around for a while. And you can understand that it's sort of an infectious idea. I often joked with people in the past that we knew that reality was a simulation because how else in the world would your keys end up in the freezer or socks missing in the dryer? And the joke was every time the system crashed and they had to reset it, some of the variables that pointed out where objects were supposed to be got scrambled up, and that's how those weird things would happen. So it was just a joke, but it's a joke that makes people think. That germ remains in your mind, that thought, that little idea. And many people at this point realize that no matter how complicated our world is, if somebody can build a larger, better, more powerful computer than we have, they could simulate a fair portion of it. So, how do we know that reality is real? Our understanding of this can be tempered by the fact that the world's most powerful computing right now is devoted to simulating the effects of nuclear transformations. We have tiny simulations of a tiny portion of our universe that reflects the operations of either string theory or chromodynamic theories, the study of the tiniest fractions of existence in our universe. And by looking at them, we can make predictions about how quantum mechanics and how certain particle theories can work. And so this is an interesting thought that our most powerful computing is already being used to simulate tiny bits of reality. And it only goes to extend from there that if we can make even more powerful, cheaper computers, that people would simulate other portions of reality. Now, we have to look at the consequences of living in a simulation. If this really is a simulation, then there should be some signs that we could detect. One of them is, as mentioned earlier, the possibility that certain reactions would leave a signature, such as cosmic rays showing a shift in their spectrum. Why would this be? It's because in order to make a particle move from one point to another, in reality, the universe has tiny steps of space-time, tiny steps of energy called quanta, and these little bits are shown to actually be discrete, in other words, separate. But the catch is this: those tiny bits don't have hard-defined limits to them like little boxes. Instead, they smear out like waveforms and overlap. And you may have heard of something called the uncertainty principle. Well, the uncertainty principle explains to a degree why this is so. And so we might say, well, it isn't actually digital, it's just tiny portions that are uncertain and blur into each other. And that seems like a very reasonable explanation. But now we're looking at quantum computing, something completely different from the previous digital computing that everybody is familiar with. And quantum computing would be using waveforms that overlap. And when we interpret the structure of a quantum wave, it is affected by all the other quantum waves around it. So if you look at it from this standpoint, we could imagine that our universe appears to be a digital simulation based on quantum wave effects. In other words, once we reach the point where we have powerful, high-range quantum computers, we would be able to make simulations thousands of times more detailed and realistic than the simulations that we can create now. At some point, how realistic does a simulation become? And is it something that is capable for passing off as reality? This is the real issue. Let's assume for a moment that we actually did have a system that simulated reality. What would the consequences be? And this is the most important part. Imagine you have a computer, and in the computer, you're going to write a program that simulates another computer. Now, this is done pretty often by people who design computer chips. They have to know how well the thing is going to operate and if there are going to be any issues with it. So they actually write what's called an emulator. And an emulator program acts just exactly like the computer you're trying to build before the first piece of silicon is actually ever made. So by running an emulator, you can see how it's going to perform. But the issue is, it can only perform as quickly or less quickly than the computer that is simulating it. So if your computer has, let's say, 1 billion instructions per second, and you're simulating a computer that runs as fast as it can, if it takes 10 to 20 instructions for your computer to simulate the other computer, then it's going to run at least 10 to 20 times slower than your computer. And the only way to make the new computer run as fast as it should is to not be emulated. Now, if you were that computer chip that's running in the emulator, you would have no way of knowing that. You would only know that you're running as you should. And that's the crux of the argument. But it also leads us to an interesting thought. If reality is a simulation, there may be a limit to how many instructions can be performed in a given instant of time. And if we start building other simulations of extremely high resolution and fidelity, and we start running many simulations, we might reach a point where our world bogs down the computer that is running our reality. Now, this is an interesting thought, that perhaps running hundreds, thousands, or millions of virtual worlds in our world would make our world, if it is a virtual, crawl to a halt. That we literally could overload the processor or cause it to crash. Some people have proposed that the singularity, the coming point in time where we have so much computing and so much information that we can't predict what happens next, may actually be the thing that triggers the shutdown of our simulated world, if indeed it is a simulation. This is all very well and it's all theoretical, but is there any portion of anything we've done in reality that indicates to us that it might be true? Oddly enough, there is. Work done by physicist Stephen Hawking shows that when something falls in a black hole, the information that it contains does not end up in the volume of the black hole, but because of the way it works, it ends up spread over the surface of the black hole. Now, this would mean if you put an awful lot of stuff into a black hole and everything full of information ended up falling into that black hole, the information on the surface would increase hugely, but not in the volume. And this leads to a principle called the holographic universe, that the surface of a black hole is only two-dimensional, and the information ends up on that two-dimensional surface, not inside the three- or four-dimensional volume contained within the hole. This also leads to another consequence. If you have enough information compacted densely enough in a small enough space, it too can lead to the formation of another black hole. It's very strange to think that not only matter or energy can make a black hole, but information can also. So this brings us to the point where we have to consider how big a black hole can be versus how much information there is. There is a direct relationship. This is a true result of the modeling of theoretical physics behind black holes, gravity, and space-time. So there are actually some consequences that suggest to us that the world could be a simulation, and that is one of them. So let's see if we can summarize the idea of our world being virtual and some implications. The concept was raised clearly in science fiction in the late 1950s and early 1960s, and the growth of computing power in simulating weather, stock market prices, and other real-world phenomena was helpful in developing virtual worlds of our own, known as video games. Now, philosophers and scientists have since come to realize that we don't know of anything that would preclude our world from being a simulation. There's no science or theory that could dismiss the possibility. Furthermore, work by Stephen Hawking shows that black holes would exhibit a strange effect where the size of the black hole would be related to the amount of information that it contains. And this creates the idea that our universe is a hologram. This is because information density is related to the two-dimensional surface area of the black hole, not its volume. Other scientists have found what appears to be error correction codes in the equations of string theory, which might be a foundation of the structure of our universe. And for our universe to be stable, or for any universe to be stable, it might just be a natural part of reality, but we can't be certain. On top of that, if we begin making very detailed quantum mechanical virtual worlds, the processing power to do it and the density of information involved might possibly bog down any computer that is running our simulated world, like giving your computer too many tasks to do at once. And finally, if our world is a simulation, there could be some interesting consequences. For example, death becomes potentially meaningless, because if you are simulated, then your mind becomes the result of some piece of computer code, and the operator of our simulation could simply restart you, just as you might restart a game on your Nintendo. Does Mario remember the past games? Could that be one source of déjà vu? Another result of learning that our world is a simulation might be that people would stop doing good works, because then the world and its consequences might appear meaningless. A confirmation that the world is virtual could actually trigger a wave of suicides, adrenaline-related deaths, or pointless actions. If people lose the feeling that their existence has meaning, we can't be certain of how it would affect them positively. But if the world's a little more than an extremely sophisticated simulation, it might make sense to do things that make your life interesting to the programmer, so that you're not simply erased. You might want to start doing things that make you worth keeping around. Your existence might depend on becoming a very interesting person, someone worth watching for sheer entertainment value. But we can't be certain if that's the point of it all. You see, all this is just a theory right now. But theories can be right or wrong, or partially right. So far, we don't know what the answer is. So let's take some questions and listen to some of your ideas for the second part of the show. Send us your thoughts through our forum, and we'll address the most interesting ones. Okay, well, first of all, we've had an interesting first half of the show. Let's see if we can get some questions from some people. And I have this is an anonymous post, and it says, I've played Grand Theft Auto 3 and crashed the game. Could we crash the universe? That's a pretty interesting question. I don't think that's very likely, and the reason I'd say that is because all the things we see in physics don't seem to indicate anything that would wreck the way the code is running. If the universe is a simulation, then whoever programmed it paid a great deal of attention to how everything operates and whether there are going to be any sorts of problems. So if you consider we've done things like detonate nuclear bombs, and the sun is a constant nuclear process, and there are some extremely high temperatures and pressures there, you know, I don't see anything that we could possibly do that would crash the universe. Maybe if we were doing research in extremely high energy particles somewhere, something we can't even do yet here on the Earth, it might be possible. But I don't know if that's a possibility that's realistic in any sort of way. In any event, it is a pretty interesting question. I just don't think there's any way we're going to crash the universe. Now, let's see. If we look at the way the universe works, everything is done with particles, almost little building blocks that interact with each other. Whereas in a computer program, the type that we write, we usually use instructions or code. And here's the interesting part about that. In a universe such as a video game, we declare the rules by fiat. We simply say, this is what the rules are. And in fact, if we were to build a universe that way, or a simulation of a universe, it would be what I would call a universe by fiat, or UBF. In a UBF, any sort of rule can be made up at random, and they don't even have to be consistent. So I know that a lot of us have played video games and had things crash or go through a wall or do something inconsistent with reality. In the real universe, there are rules that seem to be built into the structure of it, unlike a video game. And so, in that sort of a universe, the computation that does the job of creating that universe is really the interaction of all those particles and forces. So, if you were to simulate particles and forces with very simple rules, and then you were to create a universe out of those simulated particles and forces, there's a much better chance that it's going to be far more stable and self-stabilizing or self-correcting than a universe by fiat. So that's one of the things to consider when we look at making synthetic worlds of our own, or artificial worlds. Okay, we have Gary wants to know if there could be cheat codes for the universe. Well, that's a fantastic question. I think we've got some gamers here tonight. Okay, a lot of people who play video games know that there are sometimes codes that you can enter that allow you to do things that normally would not work, and those are cheat codes. And cheat codes could exist for reality if it were a program, but again, if this is not a universe by fiat, then it's unlikely. I think that in a sense, physicists, nuclear physicists, are looking for cheat codes, or people who research physics are doing the look for cheat codes thing right now, because they're trying to find ways that we can bend the rules of reality to, let's say, create anti-gravity or whatever. And in our minds, we don't yet know the answers to those things, so the research we do could, in a sense, be looking for cheat codes. But if actual cheat codes for reality existed, it might allow you to do things like move through solid objects, or go behind the scenes, or make everything static while your time continued to run. But that, that's at this point, that's really a fantasy, but it is a fascinating idea. So it's not something we could simply, dispel without a little bit of research. Okay, so far we have actually some pretty good questions here. I've got one from N00B29, that's Noob29, Albany. And he wants to know, if the universe is a simulation, how would we go about moving to a different universe? And I think that's actually another interesting question. Okay, let's assume that you had 2 or 3 different simulations running on your computer, and you wanted to move information from one to the other. Normally, you'd have to write some sort of a program that acts as a port or a gateway to get that information from one to another. And it would be extremely unlikely that a character in one of the games or programs would have access to system functions that allow them to move into a different simulation. But there's also something else to consider. We know that our universe has a certain set of rules or laws that apply to it, and its geometry, is the mathematics behind it, is what defines how our universe acts and what it is. Well, that being the fact, we also could understand that it's quite possible that a different universe would have completely different geometry or structure or rules. And so it could be a dangerous thing to try to move from one simulation or one universe to another, because under those conditions, maybe the variables are different, maybe the code is different, and you probably couldn't function, or you might even cease to exist. So that would be a pretty dirty sort of experiment to try, and very dangerous one. So that's not something you're going to see me trying anytime soon. But the cheat code question, that's a very good one. I like that. All right, let's see who else we've got on the line and what we've got. Okay, we have another anonymous post here, and it says, if you could build any sort of universe you could, what would it be like? You know, I think that a lot of times when we start a simple project like adding a room on a house or making a custom car or doing something like that, we often think about all the things we would like to do, and we discover it takes a lot more planning to make that happen, to get all the resources in place and so forth. I think that if I had to design a universe, it would probably be pretty much exactly like the laws of physics that we have here, because you will always discover that if you change something and you don't understand how the whole system works, you're going to have some pretty horrible consequences possibly at some point in the future. So, as far as it goes, this is a pretty good universe. So, as far as the ability to make an entirely new one, I don't think I would change anything. I think I would like to know a lot more about this one before I go altering things. It's like going into somebody else's recipe and changing things around and not knowing what you did, or going into another piece of somebody else's code and changing some variables at random, thinking you're going to make things better. That's pretty unlikely on a complex system like an entire universe. I don't have any posts right now for the moment, so I'm just going to talk a little bit about the whole idea. Um, a synthetic universe is a pretty fascinating thing, and I think that we're coming up with a lot of really good candidates for that sort of thing lately. I've done a lot of video game playing and a lot of video game writing myself, and I know that when you start thinking about the simplest actions, you have to consider things like how gravity works and how impacts work, how things collide with things and rebound, how pieces fracture, how damage occurs. And there are so many details that come up when you begin to design even a video game that you have to start declaring certain limits to everything in the beginning. And I have a great phrase that I came up with a couple of years back when I was working on a project, and I realized when you have absolute, utter freedom to do anything you want, a lot of times you're stumped. You have no idea what to do next. And so I realized that actually having limits could greatly clarify your thinking and help you guide where you were going to go. And I call it the freedom of constraint. So that within a certain set of parameters, if you've cut out millions of possibilities and you're down to only like 3 to 5 possibilities, it's much, much easier to make a decision about what you're going to do and how you're going to do it. That's what I call the freedom of constraint. Something that it seems sort of paradoxical at first that if you have utter freedom to do anything you wanted, that anything is possible. Yes, that's true. But when it really comes down to it, in those sorts of circumstances, it's next to impossible to figure out what you want to do. It's hard. So if you give yourself a certain scope to work within, it becomes much easier to do. And I think that designing a universe would, no question, be one of those sorts of projects. Okay, and I've got a good one here. Frank in Arizona says, "What are the social issues if this is the only universe there is? If we find that this isn't a simulation, but it's the only universe there is, what sort of answer is that? I suppose to what people have been thinking that it's possible that there are many, many universes." Um, even physics postulates that there's got to be a lot of universes, and the reasons for it are numerous, and one of them stems deeply from quantum mechanics. The fact that the solution to a problem often involves waveforms of very great complexity, and getting those waveforms together into one place to solve the question of how real or how solid something is, that's a real problem with trying to develop quantum computing, trying to isolate other waveforms and keep your qubits, your quantum bits, separate from each other so they don't collapse. If this is the only universe, then, and I don't think that it is, but if it were, then I think that life would pretty much go on as it does. I don't see any huge differences in what people would think or what they would do. So I think that's probably the easiest answer out of the questions that have been asked. So, okay, what I'm going to do right now is give a brief update on the Singularity Watch, and that is basically that we have seen some new advances recently in fields where they have finally come up with a cure for Alzheimer's, which is being tested right now, and they return full memory function in the patients that have had it. And they also have in the wings stem cell cures for MS, multiple sclerosis, which I find was fascinating. And what we're really looking at here is the growth of information and medical technology has become so rapid that we have new treatments emerging almost monthly at this point for diseases that were previously thought insoluble or incurable. That's going to bring us to a point where it's possible to reverse many things, including aging. They've already done some previous, thought impossible tests to reverse the aging in cells. Apparently, what they've found is a certain set of proteins and conditions that will cause a cell to become younger. So there are some tests being done right now which may actually have the potential to halt or reverse aging. And that does bring us even closer to the point where people could live 100 or 1,000 or years or permanently. But I think the actual solution will come as a hybrid of machine technology, such as nanotechnology, robotics technology, and human life. That's the only way to really make a body that isn't going to decay or age, that I think. And that's just my opinion, but it's based on some science, engineering, and physics. So I hope you've enjoyed this show. This is our very first podcast. I know it's a little rough, but it's got some good points, and we're going to have some really fascinating material. Our next show is going to be, are we destroying our world? And that's going to be a good one. We're going to talk about a lot of things like fracking and plastics and air pollution and biological disasters. And we're going to look at some of the evidence for those things and how we can get around them. So thank you for listening today. It's been a great show, and I'm looking forward to a lot more questions. We're going to have a lot of fun, and if this continues to grow, we're going to go to an hour format instead of a half hour or so. So thank you very much. We hope you've enjoyed Talk Universe. This is Sir Charles Schultz, and we'll do another one real soon. Come back and listen. Thank you.